Okay, so good evening, good afternoon, good morning, everyone. I hope everyone is doing well. So today's lesson is going to be on sets. So today's lesson is going to be on sets. So first of all, a set is written in a root form. A set is written in a root form. And if its exact value cannot be determined, then we can classify it as a set. But if its exact value can be determined, it is not a set. So I take it once again. A number can be classified as a set if 1, it is written in a root form. 2, its exact value cannot be determined. 1, if it is written in a root form. 2, if its exact value cannot be determined. So for example, if we have the square root of 4, this is not a set. This is not a set because the square root of 4 is 2. So the exact value or the exact answer for the square root of 4 is 2. So the square root of 4 is not an example of a set. Or how did we know that the square root of 4 is 2? You realize that when 2 multiplies itself, we get 4. When 2 multiplies itself, it gives us this number. That is why the square root of 4 is 2. When I take the square root of 9, you realize that when 3 multiplies itself, it gives us this number. So it means that the square root of 9 is 3. So the square root of 9 is not a set. But the square root of 5 is a set because we don't have any number that multiplies itself to get 5. For example, 1 times 1 is going to give us 1. 2 times 2 is going to give us 4. 3 times 3 is going to give us 3 times 3. 3 times 3 is going to give us 9. 4 times 4 is going to give us 16. So the square root of 5 is a set because its exact value cannot be determined. So I'll list down some root forms that are not considered as sets. So I'll list down some root forms that are not considered as sets. So we have the square root of 4. We have the square root of 4. We have the square root of 9. We have the square root of 16. We have the square root of 25. We have the square root of 36. We have the square root of 49. We have the square root of 64. We have the square root of um, 81. We have the square root of 100. We have the square root of 121. We have the square root of 144. We have the square root of 169. We have the square root of 196. Then we have the square root of 225. So the square root of 4 gives us the square root of 4 gives us 2. Square root of 9 gives us 3. Gives us 4. Square root of 5. So square root of 25 gives us 5. Square root of 36 gives us 6. Square root of 49 gives us 7. Square root of 64 gives us 8. Square root of 81, 9. Square root of 100, 10. Square root of 121, 11. Square root of 144, 12. Square root of 169, 13. Square root of 196, 14. And then the square root of 225 is 15. So we should know the exact values for these sets that I have listed. So as a math student, you should know the exact values of these root forms as I have listed. Okay. So let's dive into how to perform operations on sets. So the first operation we are going to talk about is the addition operation on sets. Now note that before you can add two or more sets, the number inside the root, so the number in the root should be the same. So before you can add two or more sets, the number inside the roots should be the same. For example, you can add square root of 2 and 3 root 2. But you cannot add square root of 2 and 2 root 3. You cannot add these two sets because the values inside the square root are not the same. But you can add these two sets because the value inside the square root are the same. So first of all, the values inside the square root should be the same. So let's try. Another thing is when you have the square root of 5. Now, we can simply say that the number inside the square root is 5. What about outside the square root? So outside the square root, since we don't have anything outside the square root, the number outside the square root is 1. So if a square root is written without a number outside, the number outside the square root is 1. So that is another thing you have to keep inside your head. So it means that when you add two or more sets or subtract two or more sets and you get 0 as an answer, you don't have to leave it blank. You have to write the 0, because if you leave it, it is believed that the number outside is 1. So if you get 0 as your answer, it means you have to write the 0 or else it will be taken as 1. Okay, so let's take this question. You have to find the value of 3 root 2 plus root 2 plus 4 root 2. So we have to find the value of 3 root 2 plus root 2 plus 4 root 2. So how are we going to tackle this? So we have 3 root 2 plus root 2 plus 4 root 2. So because the numbers inside the square roots are the same, we are just going to pick one of them. So the square root of 2. Because the number inside the square roots are the same, we are going to pick one of them. So what we are going to do next is to add all the numbers outside the square root. So for the first one, the number outside the square root is 3. So for the second one, since there is nothing outside the square root, the number outside the square root is 1. And the last one, the number outside the square root is 4. So I have 3 plus 1 plus 4. And 3 plus 1 plus 4 is going to give me 8. Then I bring my square root of 2. So my final answer is 8 root 2. So first of all, you have to check the number inside the square root if they are the same. When they are the same, then you can add the numbers outside the square root and pick one of the square roots attached to it as your answer. Okay, let's take another example. So pause this video and try question number B for me and post your answers in the comment section. The answer for this question, okay, since the numbers inside the square root are the same, I'm going to pick one of them. So the numbers outside the square root are 2. The second one is 1. And the third one is 5. So 2 plus 1 plus 5 is going to give us 8. So I have 8 root 5. This will be my final answer. Okay. Now, the same rule applies to subtraction. So you have to first check if the numbers inside the square root are the same before you subtract the numbers outside the square root. So if I have something like 3 root 2 minus root 2 plus 4 plus 4 root 2. So if I have something like this, first of all, I check the numbers inside the square root and realize that they are all the same. So I pick one of them. Then the numbers outside the square root, I have 3. The second one, I have minus 1 since there is nothing there. So I have minus 1. And then the last one is plus 4. So 3 minus 1 plus 4, I'm going to get 6. So my final answer is 6 root 2. So in dealing with addition and subtraction, we use the same principles, we use the same rules. check if the number inside the square roots are the same, and add or subtract the numbers outside the square roots. So you pause the video and try this question for me. So 3 root 2 minus root 2 minus root 2. Okay. So the solution to this question, you have 3 root 2 minus root 2 minus root 2. So the solution to this question, since the numbers inside the square roots are the same, I'm just going to pick one of them. The numbers outside the square roots are 3. The next one is minus 1. And then the last one is also minus 1. So 3 minus 1 minus 1, I get 1. So I have 1 root 2. And since we have learned that if the number outside the square root is 1, we can omit it. It means we can write our final answer to be the square root of 2. So if we write the answer without a number here, it means the number over there is 1. So we can write our final answer as square root of 2. But if we have any number, any other number apart from 1, so if our answer was 3 root 2, we cannot remove the 3. The answer is negative 1 root 2. Then we can also write our answer as negative root 2. We can take the 1 away. So apart from 1, we cannot take any number away as our final answer.